topic today is proportions. In your learning target, you're going to create and solve proportions. This is 6.2. I would highly recommend putting that in your topics section because you will be collecting or turning in your notes at the end of this unit. You need to know some vocab. Proportion is an equality of two ratios. Proportion is an equality of two ratios. It also just means two equal fractions is what it looks like. You have something like this. 2/3 is equal to 4/6. Okay? It's just two equal fractions. We're going to identify if two ratios are proportionate or not. They are proportionate if the following is true. You can multiply one fraction to get the other. Notice in the first example up here, I got 4/6 by multiplying both of them by 2. That's the easy way to solve proportions, but they're not usually that easy, especially as 7th graders. They're also proportionate if they reduce down to the same fraction, or break down into the same reduced fraction, or simplify down to the same reduced fractions. All of them are synonyms. This is the biggie. Highlight that any way you choose, but this is how we are going to check if they're proportionate. If their cross product is equal to each other. If their cross products are equal to each other, then they are proportionate. You're going to be using cross products for the remainder of this unit. So what is a cross product? Great question. All you do for cross product is multiply the diagonals. So you think cross diagonal, cross x, you make an x, multiply, okay? Product means multiply. So for example, looking 2/3, is that proportionate to 10/15? Are they a proportion? Most of us can say yes, because you know that you multiply these two by 5 to get that other fraction. But we're going to use the cross product way. Cross product, I say I'm going to go, does 2 times 15 equal, and then multiply the other diagonal, 3 times 10. Right? Stop. Does 30 equal 30? Yes, they are a proportion. So you are going to need to know that. You're going to need to know how to identify if two ratios form a proportion. Check the cross product. I want to know, does 1/9 and 9/81, is this a proportion? Check the cross product. Does 1 times 81 equal 9 times 9? 81 equals 81. Yes, they are a proportion. Okay? We use cross products to solve proportions. That's our next step. When you solve proportions, you set their cross product equal to each other. I set the cross product equal to each other. And then lastly, I just solve. Using algebra, I solve. Now these you can do mentally. A lot of times you can mentally handle this kind. It's not too often you're going to have the mental one. So I am going to set you up, setting the cross product up. So you will want to cross over your calc today as well. I always start with the variable diagonal, so I always start with 8n, or anything that has a variable. So I say 8n equals, and then multiply these two, 3 times 48. I wouldn't write that stuff in my work though. I would just figure out what 3 times 48 is first, which is 144. So I say 8n equals 144. This is 8 times n. To move times, you divide. So I'm going to divide through by 8. and I get n equals 18. I'm solving the proportion by setting their cross product equal to each other. Again, I start with my variable side. The reason I do that, I like my variable on the left. So I'm going to start with 7x is equal, and now I'm going to multiply these two. 42 times 2 is 84. Divide through by 7, x is 12. I want you to go through and set up the cross product and solve the remaining 4. And you're going to compare with the student next to you. Setting the cross product equal, I always start with my variable side. So I say 2x is equal, 8 times 5 is 40, divide by 2, x is 20. Again, I start with my variable side. 24x is equal to 6 times 20 would be 120. Divide them, and what does that equal? Somebody tell me. 5. X equals 5. Right, and then I have 12y is equal to 72. And then y is 6. And last one, 28y is equal to 7 times 8 is 56. Y is what? 2. Thanks. Okay. So awesome. We did that. We solved proportions there. This is more just solving proportion examples, setting the cross product equal to each other. I'm not going to waste the time on recording here, but I want you to go through and compare this as well with the table partner. All right, the next topic with proportions is creating a proportion that represents a word problem. I have this generic proportion set up. You're always given an object, some kind of object to another object, okay? So we're going to have one object is to another object, and how you say it like this. Object A is to object B as object A is to object B, okay? You are always given a first relationship. The first relationship that you're given is going to represent your first fraction. So it's going to always look like that. I call that my proportion skeleton. I know that there's going to be some kind of ratio going on, and a proportion is 2 equal fractions, okay, or ratio. All right, then you're given one of the other objects, and you will need to solve for the missing. Now this one a lot of kids can just do in their head, but I'm showing you how to represent this with a proportion. Almost all of 7th grade word problems on an MCA is going to be a proportion related. So as long as you feel confident with setting up a proportion, you are going to do well. Remember also, money is always on top. Okay, money is always on top. You need to know that. All right, so here I am. First one, 2 baseballs cost $6. There it is. My first relationship. I have money and baseballs. So I have money is to baseballs. Creating my generic proportion skeleton, money is always going to be on top, baseballs on the bottom. So 2 baseballs cost $6. How much are 7 baseballs going to cost? So $6 is to 2 baseballs as, how much will 7 baseballs cost? Is 7 going to go on top or bottom? Bottom. Baseballs are on bottom. Variable in the unknown. Now I set up the proportion. 2x equals 42. X equals 21. There is a multiple strategies to solve this. I'm only showing you the proportion way. Some of you figure out how much for 1 and then times it by 7. That's okay. It's A-okay. All right. Next ones. If 4 CDs cost $54, how much are 3 CDs going to cost? So my relationship is money to CDs. Do you agree with me? Money is to CDs. The first fact I know, where I know both of them, is right there. 4 CDs for $54. $54 goes on top because it's money. CDs on the bottom. $54 is to 4 CDs as how much do 3 CDs cost? Is the 3 going on the top or the bottom? Bottom. Because CDs are on the bottom. I always write this, and you'll want to do that for like tomorrow with that big packet of word problems. You'll want to do that. Figure out your relationship and then just fill in the blanks. Cross product, 4x equals, I don't know what that is.
162.
Thank you. And now tell me what x is.
40.5.
Okay, I worked so hard for this math. 40.5, no, it's not 40.5. A cashier isn't going to say $40.5, please. And we're talking about money, so we need to keep that in mind. The cashier would say $40.50. Okay, I know it's very like, okay, it's the same thing, but we got to think of real life context. Okay, if your money, you got to include the cents. 3 pants cost $32. How many can we buy for $100? So what's my relationship?
Money pants.
Money pants. Money is to pants. Creating my skeleton, proportion skeleton, now I just fill in the blanks. 3 pants cost $32. So 3 pants, pants go on bottom, money on top. How many can you buy for 100? Is that 100 going on the top or bottom?
Top.
Top, because it's money. And now I can set up my proportion. So I say 32x, setting up their cross product when we solve, equals 300. Somebody tell me, I don't know where my calc is.
$9.38.
$9.38? No. Now we're talking about pants, not money. So can we buy 0.38 pairs of pants? Yes or no? No. So I can only buy 9 pairs of pants. I have a little money left over. Maybe I can run to Starbucks or Canada. So I say I can buy 9 pairs of pants. Okay? It's 9.38. Real life says no, you can't buy that much. So I say I can buy 9 pants. 4 left-handed students are to 18 right-handed, right? So right now I'm given left to right. How many left-handed students if there are 420 students? They didn't say right there, uh-oh. How many left-handed if there's 420 students? It looks to me like I need left to a total. That's what I need, and oh my goodness, be careful. This is one of the most common proportions they set up, where they try to trick you, thinking that you're going to do left to right, but you're really doing left is to total, because this is how many left-handed if there's a total of 420 kids. So I need left is to total as left is to total. Okay, so setting it up, looks like I have 4 left-handed at first, right? How many total kids at first? If I had 4 left and 18 right, how many total? 22. 4 is to 22. As, how many left-handed if there's 420 students? Is 420 a total or a left? Total, so it goes on the bottom. Set up the cross product. I always, again, start with my variable diagonal.